Hey guys, and welcome to your 8.3 Part 1 notes. So just like 8.1 and 8.2, I'm going to split these notes between sequences and series. So first part will be geometric sequences, and the second part will be geometric series. Okay, so your geometric sequence is the ratio of any term to the previous term that is constant. Okay, so instead, before we had things that we were adding or subtracting, this is going to look like either multiplication or division. And when we write that, instead of a D for our common difference, we are going to have an R for our constant or common ratio. If it is division, we want to actually write it as multiplication. So for example, if we're dividing by 2, then R would be 1/2, because that would be the same as multiplying by 1/2. So just keep that in mind as we go through and we label what R is. Okay, so at the bottom here I have one non-example and one example. So notice that from here to here I would be multiplying by 2, and then I can't multiply by 2 to get to the next one. Okay, I'm actually adding different numbers each time. Okay, so this one would be a non-example. My example over here, it looks like it is dividing by 4 each time. So I'm looking at my numbers, it's dividing by 4. So remember, if I were to write my common ratio, that would look like 1/4, because it would be the same thing as multiplying by 1/4. Okay, so we're going to tell whether each sequence is geometric or not. So we're looking for something that is being multiplied over and over again, or something that is being divided over and over again, and we'll find out what that common ratio is. So for our first example here, to get from 5 to 15, that's multiplying by 3, and then 15 to 45, that's multiplying by 3, and then 45 to 135, that's again multiplying by 3. So this one is, yes, this is geometric, and our common ratio would be 3. We're multiplying by 3. Okay. The second one, it is switching back and forth by a negative sign. So that's telling me that I am probably multiplying or dividing by a negative number. And it looks like my numbers themselves are getting smaller. So I'm dividing by a negative number. So if I divide by a -2 here, and then divide by a -2, and then divide by a -2 again, this one is yes, and my ratio would be a -1/2. Because remember, division, it looks like a fraction as multiplication, and it was a negative number. Okay, and the last one down here, how to get from 12 to 9, 9 to 9/4, and 9/4 to 27/8. I'm going to look and see, is there anything I can divide by to get there? And I don't see it, but remember, it just has to be a common ratio. So that ratio could be something other than a basic 1/2, 1/4, okay? So what I'm looking for is a fraction that works when I multiply these. So 12 times something is going to get me to 9. Okay, so what I'm really doing is trying to figure out what that ratio is. So I'm going to divide by 12, and I get 3/4. Okay, so that's one way you can figure out if you're not quite sure what that pattern is. So I'm actually multiplying by 3/4 each time in order to get that next number in the sequence. So what I really want to make sure of is that I'm not just assuming that the same thing works every time. So on this one, I'm going to do the same thing and get 9x equals 9/4. So I want to make sure that when I solve, I actually end up with the same thing. So I notice on this one that I don't. When I do this, I end up with 1/4 instead, which means this is instead being multiplied by 1/4. So since it is not the same every time, this is not geometric. So once we have identified a sequence as geometric, we do have rules for writing those sequences. Okay, just like we did for our arithmetic sequences, we can write that with our geometric. So this is our nth term, then we have our first term being plugged in. R is our common ratio, and then remember, n we leave in the equation because that allows us to plug in any number and find that term number. So we're going to start by writing the rules of the nth terms of each of these sequences and then finding a of 7, so the 7th term. Okay, So since I know these are actual geometric sequences because it's telling me to write the rule, I'm going to figure out what's happening each time as I look at these sequences. So to get from 27 to 9, 9 to 3, and then 3 to 1, each time I am dividing by 3. So remember, when I'm dividing, it's the same thing as multiplying by our fraction. So my ratio is going to be 1/3. Okay, so using that formula that was on the last page, we are going to plug in what we know. So this is our first term, that's 27. Our ratio is 1/3. And we want to leave in our equation so that we would be able to plug anything in as our nth term. So there would be our rule. And then it says find the 7th term. So what I'm going to do is plug in a 7 for my n. And then simplify that. And when I do, I get 1/27. Okay, for the second one over here, again, if fractions are something you struggle with, do what I did and set it up. So I have 2x, so 2 times something equals a -8/3. Divide this by 2, and you end up with -4/3 as what's happening each time. So our ratio is going to be a -4/3. Okay, so I'm going to plug that in. Remember, your first term is the first thing we plug in. Our ratio goes inside the parentheses. And then I'm going to leave n minus 1 because I want to write the rule for the nth term before I find out what the 7th term is. So I'm plugging in a 7 for my n. And when I simplify, I get a really large fraction because every time I'm multiplying by a -4/3. So I have 8,192 over 729. Okay, for our next example, we're going to write the rule for the geometric sequence where the common ratio is 2, so r is 2, and our 4th term is 12. So I'm going to use that formula that we've been given to write the rule. Okay, and I know that my ratio is 2, so I'm going to go ahead and plug that in there. And what is happening over here is I'm giving information, but I'm not given my first term. So I have to plug in that A4, sub 4, is going to be my 12th, that term is 12. Okay, so that tells me my term is 12, and the term number, it's the 4th term. Okay, so I'm plugging in 4 for n. So now when I simplify this, I get 8 times A sub 1 equals 12. I'm going to divide by 8 on both sides. So now I know my first term is actually 3/2. And once you have your first term, you can go back to your original equation, plug that in, plug in our ratio, and we will have our rule for our nth term. So 3/2 times 2 to the n minus 1 power. For the next example, we're given a sequence, so now we have to figure out what that ratio is, so what is happening each time. So for this one, 6 to 2, hopefully everybody sees that's divided by 3. 2 divided by 3 does get me 2/3. 2/3 divided by 3 does get me 2/9. So this one, remember, we're going to write that as if we were multiplying. So I'm going to say that is 1/3 as my ratio. And I know this is my first term in my sequence. Here, that's a 6. So when I write my equation, remember you have your first term times your ratio to the n minus 1 power. So I'm going to have A sub n equals 6 to the 1/3, or times 1/3 to the n minus 1. Okay, so there's my equation. And then what I have to do now is still find the 8th term. So I'm going to plug in what my 8th term would be. That means I need an 8 in for n. And then simplify, I'm going to plug all of that into my calculator, and I end up with 2 over 729. For my example down at the bottom, it says write a rule. The common ratio is 4, so this tells me r is 4, and the 4th term is -192. So this is very similar to the one we did on the slide previous to this. So I know that my 4th term is -192. I don't know what my first term is. My common ratio is 4, And remember, n is the term number, so that's my fourth term minus 1. Okay, so there's my common ratios in the parentheses. Fourth term is that n power. Now I'm going to simplify as much as I can, so I'm going to simplify 4 to the third power, which is 64. And then I'm going to divide by 64 on both sides. So I get that my first term is negative 3. And then I'm going to take that and plug that back in to our rule, which says it's the first term times the ratio to the n minus 1 power. So that would be the rule for this sequence. For the last two examples, I'm just going to give you two terms and their position in the sequence. So this is the second term, and that term number is 12. Okay, this is the fifth term, and the fifth term is negative 768. So we're going to use what we know about our formula to find out how to write a rule for this. Okay, so for the second term, I know that that term is 12. I don't know what my first term is or what my ratio is, but I do know that the term number is 2. So I'm going to simplify right there my exponent. So I know 2 minus 1 is just 1. So this is the same thing as 12 equals a sub 1 times r. Okay, and then I'm going to do the same thing for the next term. So I know this one would be negative 768. I don't know what my first term is or my r, but I know that this is the fifth term. So I'm plugging in 5 for n in the formula. Okay, I'm going to simplify again those exponents. So that gives me negative 768 equals a sub 1 times r, this time to the fourth power. Okay. What I'm going to do now is I notice that both of them have the same variables. So I'm going to go ahead and solve for one of the variables. So to me, I'm going to take this first equation over here and I'm going to solve for r. Or solve for our first term. So in this case, if I want to solve for my first term, I'm going to get rid of the r. Okay, so that tells me my first term is 12 divided by r. And what I can do now is take that and actually plug it in to the other formula. So I have negative 768 equals 12 over r times r to the fourth power. There we go. Okay, so now I'm going to simplify this in order to figure out what r is. So this would be, I'm simplifying these r's right here. I have an r to the fourth on top and r on bottom. So that would give me 12r cubed equals negative 768. I'm going to divide by 12. And I get r cubed is negative 64. So when I take the cube root, I get 4. Okay. Then I'm going to take that and I'm going to plug it back in up here in order to figure out what my first term is. So my first term is 12 divided by negative 4. So this gives me negative 3 as my first term. And once I have both of those, I'm going to plug those in up here. So we said this is negative 3. This is negative 4, so my rule looks like negative 3 times negative 4 to the n minus 1 power. Okay, for the last example, it's going to be very similar. So again, I am using that original formula to help me out. I don't know a whole lot, but I'm going to plug in what I do know. So for this first one, I'm going to have negative 160 equals my first term times r to the 3 minus 1 power. So negative 160 equals a sub 1 times r squared. And then I'm going to do the same thing for the next term, or the sixth term, because that's what I'm given, sixth term. So I have a sub 1 times r and 6 minus 1, which is going to be r to the fifth power. Okay, again, I'm going to solve to get my first term by itself. So I'm going to divide by r squared. And then I'm going to take that and I'm going to plug that in for the first term of the other equation. Okay, so I have an r to the fifth on top, r squared on bottom. So that's going to simplify to a negative 160 r cubed. I'm going to divide by that negative 160. So I get that r cubed is negative 1/8. So r is negative 1/2. Right? Again, I'm going to take that and I'm going to plug that back in up here. I get my first term is a negative 640, and I plug that in, so I get negative 640 times negative 1/2